we're factoring, we're breaking up the area into a length and width part. So when we're factoring quadratics, it really is the same thing, but the problem is the area is not shown as individual parts, because that 5x is really a sum of the two diagonal pieces along that. So those are like terms that get added up to that 5x. To really see how this factors, to see the lengths and width, we really need to understand how to split up that 5. And the key to splitting up that 5 is we look at the last number 6, because that still is a product. And that last number 6 is a product of the length along here and width along here. But this length here has to do with something with that 2. And this length over here along the horizontal has to do with something with that 3 there. In fact, they share common factors. They have to, because they share common side lengths. So in order to split up the 5x, we just have to ask ourselves, what two numbers multiply to give us an area of 6, but add to give us this area of 5x when we add these two areas together. And so when we factor this is how the question we ask ourselves. What two numbers multiply to 6 and add to 5? Well, the numbers are going to be plus 3 and plus 2. And we can see that as well in terms of our lengths. Here we have a common factor of 3 along this vertical, so that's 3. We know the common factor along this vertical is x, so that length must be x plus 3. And we can divide to find the other lengths, but we could also find common factors this way. We get a common factor of x. That means that this area here must be x times x, or x squared. Okay, and then along here we have a common factor of 2, so this length must be x plus 2. And this then justifies our length and width of x plus 3 as our length, x plus 2 as our width, and then this x squared plus 5x plus 6 indicates the area made by those two lengths and widths.